Hello again. In this lesson we're going to talk about prime factorization and prime power factorization. They're very similar and you'll pick up one as soon as you get the other. Okay, so we're going to basically look at four examples here. We'll start with 44, a relatively small number. We're going to break this down into two numbers that multiply to 44. It's best if you can find numbers that are about equal in size. It'll break down a little bit quicker. But here we'll break it down into 4 and 11. Then the 4 we could break down into 2 and 2. You always want to keep breaking down each number into the numbers that could possibly go into it until you're left with just prime numbers. So we have 2, 2, and 11. Those are all prime numbers. So the prime factorization is going to be the ends of this tree-like system we've made here. So it's a 2, and an 11. And we're going to multiply those three numbers because 2 times 2 times 11 is 44. So we've made the factors and we've made a prime factorization because all of those are prime. So that's the prime factorization of 44. Let's move on and try another one. So let's look at 72. Again, we could break this down into 36 times 2, but I'm going to break it down into two numbers that are closer to each other. So I'm going to break it down into 9 and 8, and you probably would have seen that one first. This will just kind of keep our tree a little bit balanced. The 9 will break down into 3 and 3, the 8 will break down into 4 and 2, and that 4 will break down into another 2 and another 2. So just look at the ends. A 3, those are on the end. This 2's on an end, that 2's on an end, and that 2's on an end. So we've got 1, 2, 2 2's, 3 2's, a 3, and another 3. That brings me to another point. Notice that the 3's came first here, the way I happen to write this. But in the prime factorization, I wrote them in numerical order, increasing from left to right. That is the standard way that we'd write a prime factorization. Okay, so let's go ahead and look at some bigger numbers. 396. Remember your divisibility rules when you're trying to find the prime factorization of a number. I know that 3 plus 9 plus 6 is 18. So I know that 18 is divisible by 9, and our rules are that if the sum of the digits is divisible by 9, then the number itself is divisible by 9. So I know 9 is one of my prime factors, or not one of my factors. And let's see, 9 would go into 39 4 times, leaving me 36, so 44 times. Okay, now we've broken those into more manageable numbers. The 9 breaks into 3 and 3, the 44 breaks down into 4 and 11, and the 4 breaks down into 2 and 2. Okay, so let's go in order from least to greatest. We've got 1, 2, 2 2's, 1, 3, 2 3's, and an 11 in order from least to greatest. Wonderful. 144. Again, there's lots of ways to break this down, but looking for 12 and 12 will definitely help you. Those are the most balanced there. And now it really is going to be easy because whatever we do to one side is going to be the same as the other side. We'll just break them both down here together. And there is our little factor tree. So the prime factorization for this will have 1, 2, 2 2's, 3 2's, 4 2's, and 2 3's here. Great. These are all the prime factorizations. But there is another way, and perhaps a slightly better way, to write some of these with the prime power factorization. So the prime power factorization is going to be where we use exponents to kind of condense this factorization. So we have 2 2's. 2 times 2 can also be written as 2 squared. So by condensing any repeated factors by using exponents is the prime power factorization. So in this number 2, for factoring 72, we had 3 2's. So that's 2 times 2 times 2, or 2 to the third power. And we also have 3 twice, so that's 3 to the second power. So that's the prime power factorization. Then we have 2 to the second power, 3 to the second power, 11. The prime power factorization. Over here we have 4 2's, so that's 2 to the fourth power, 3 to the second power, and those are the prime power factorizations.